Good morning, dear students. Here, that is a new chapter, chapter number 12, that is electricity. This is part 1 of the chapter. Now, let me tell you what we will learn in this chapter. That is electric current and circuit, electric potential and potential difference, and circuit diagram. These 3 points we are going to discuss in this part. So, let me start. Electricity has an important place in modern society. Without electricity, we cannot even imagine our life. It is a controllable and convenient form of energy for a variety of uses in homes, schools, hospitals, industries, and so on. Everywhere, in every aspect of life, electricity has its own importance. It is impossible to think about life without electricity. Now, what constitutes electricity? How does it flow in an electric circuit? What are the factors that control or regulate the current through an electric circuit? All these points, all these doubts we are going to solve in this chapter. Okay. So let me start the first point, electric current and electric circuit. See, you are familiar with air current and water current. You know that flowing water constitute water currents in rivers, and similarly, if the electric charge flows through a conductor, we say that there is an electric current in the conductor. That conductor may be a metallic wire through which the current is flowing. Okay. In a torch, we know that the cells provide flow of charge or an electric current through the torch bulb to glow. You have also seen that the torch gives light only when it is switched on. So what is the work of the switch? What does it do? A switch makes a conducting link between the cell and the bulb. A continuous and closed path of an electric current is called an electric circuit. Now, if the circuit is broken, now if the circuit is broken anywhere, or suppose if the switch of the torch is turned off, the current stops flowing and the bulb does not glow. So that is the main task of the switch, to close the path so that the current can flow and the bulb can glow. How do we express electric current, or what is electric current? Electric current is expressed by the amount of charge flowing through a particular area in unit time. In other words, simply we can say electric current is the rate of flow of electric charges. That is the definition of electric current. In circuits using metallic wires, electrons constitute the flow of charges. However, electrons were not known at the time when the phenomena of electricity was first observed. So, electric current was considered to be the flow of positive charges, and the direction of flow of positive charges was taken to be the direction of electric current. Conventionally, in an electric circuit, the direction of electric current is taken as opposite to the direction of the flow of electrons that are negative charges. Okay, here in the picture you can see that is the battery. From this battery the current is supplied over here. Okay, and that is flow of electrons in this direction. In the circuit the current will flow from plus to negative, positive to negative. Okay, and here this is the flow of conventional current. Electric current is the rate of flow of electric charge. Very simple, very easy definition. If a net charge Q flows across any cross section of a conductor in time t, then the current I through the cross section is I is equal to Q upon T. This is the formula of electric current. I is equal to Q upon T. The SI unit of electric charge is Coulomb. Okay, and that is equivalent to the charge contained in nearly 6 into 10 to the power 8 electrons. 1 coulomb is equal to 6 into 10 to the power 8 electrons. Okay, and you know 1 electron carries 1.6 into 10 to the power minus 19 coulomb charge. The electric current is expressed by a unit called ampere, and that is named after a French scientist, André-Marie Ampere. 1 ampere is constituted by the flow of 1 coulomb of charge per second. That is 1A is equal to 1C upon 1S, means I is equal to Q upon T. Small quantities of current are expressed in milliampere or microampere. 1 milliampere is equal to 10 to the power minus 3A, or 1 microampere is equal to 10 to the power minus 6A. And the instrument that is used to measure the current is ammeter. Here you can see ammeter. One very important thing about ammeter is always connected in series in any electric circuit. Okay. Here you can see the figure that shows the schematic diagram of a typical electric circuit, and that has cell, electric bulb, ammeter, and a plug key. Note that the electric current flows in the circuit from the positive terminal to the negative terminal of the cell through the bulb and the ammeter. Okay, see, this is the battery. यहाँ पर this is the positive end of the battery, and here this is negative end of the battery. Okay, from the positive, current will flow from positive to negative. Positive to negative. This is bulb, and the ammeter is connected over here in series to measure the electric current, and that is the plug. This is simple electric circuit. Okay. One example is given in your book, example 12.1. Let me read out the example for you, and that is a current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. That is T. 10 minutes, and that is I. Now you have to find out the amount of electric charge that flows through the electric circuit. Okay, so I is equal to 0.5A, T is equal to 10 minutes, and when we will convert the minute into seconds, that will be 10 into 60, 600 seconds. Now we will use here the formula I is equal to Q upon T. I is equal to Q upon T. Okay, the value of I is given, the value of T is given, and you have to find out the value of Q. So after cross multiplication, the formula will become Q is equal to I T. Okay, so now substitute the value of I and T, and you will get the answer for Q. That is 300 coulomb. Fine. Okay, what does an electric circuit mean? The definition is given over there. Electric circuit is the closed path made by using battery, plug key. The second one is define the unit of current. Unit of current is ampere, and unit of current is ampere, and ampere can be defined by the flow of 1 coulomb of charge per second. That is unit of current. I is equal to Q upon T. This is the formula of current. If Q is equal to 1 coulomb and T is equal to 1 second, consider this small t. Then the I will become 1 coulomb per 1 second, that is 1 ampere. So definition of 1 ampere is if 1 coulomb charge is passed in 1 second through cross-sectional area of any conductor, the current flowing through that conductor is 1 ampere. Calculate the number of electrons constituting 1 coulomb of charge. Okay. The formula is Q is equal to NQE, where Q is total charge, N is number of electron, and Q is charge on one electron. So Q is equal to 1 coulomb, number of electron, and we have to find out. QE is equal to 1.6 into 10 to the power minus 19. This is charge on one electron. Now from here easily we can find out value of N, that is 6.25 into 10 to the power 18. Electric potential and potential difference. What makes the electric charge to flow? See, that can be explained with the help of the flow of water. Now see, charges do not flow in a copper wire by themselves. Just as water in a perfectly horizontal tube does not flow. If a pipe is horizontal, water will not flow automatically by itself. Water needs a force to be pumped, then only it will move inside the pipe. Or the pipe should not be horizontal, then only water will flow. In the same manner, electric current will also not flow by itself. It also needs a push. Okay. So here, as I told you, if one end of the tube is connected to a tank of water kept at a higher level, such that there is a pressure difference between two ends of the tube, then only the water will flow out of the other end of the tube. Otherwise, water will not flow. In the same manner, for flow of charges in conducting metallic wire, the gravity, of course, gravity has no role to play in conduction of electric current or electric charge. The electrons move only if there is a difference of electric pressure. Let me tell you, when does water flow? When there is a pressure or a height difference, then only water will flow. In the same manner, electricity will flow if there is a difference in electric pressure, and that difference in electric pressure is called potential difference. Okay, this difference of potential may be produced by a battery consisting of one or more than one electric cells. The chemical action within a cell generates the potential difference across the terminals of the cell. So, the electric potential difference between 2 points in an electric circuit carrying some current is the work done to move a unit charge from one point to another. So, potential difference is denoted by V, and potential difference between 2 points is work done upon charge. V is equal to W upon Q. That is the formula to find potential difference. SI unit of electric potential difference is volt, and that is named after Alessandro Volta, who was an Italian physicist. 1 volt can be defined as the potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to another. See, we can solve it from the formula V is equal to W upon Q. So V is 1 volt, W is equal to 1 joule, Q is equal to 1 coulomb. So 1 volt is equal to 1 joule upon 1 coulomb. The potential difference is measured by the means of an instrument called voltmeter. Here you can see the voltmeter. The voltmeter is always connected in parallel. Very important point. If you remember right now in, I think, third or 2-3 slides back, I told you ammeter is always connected in series while voltmeter is always connected in parallel. Okay. Here is example 12.2. Let me read the example for you. How much work is done in moving a charge of 2 coulomb across 2 points having a potential difference 12V. Okay, V is equal to 12 and C is equal to 2, and you have to find out work. Very simple. Use the formula V is equal to W upon Q. Here the value of V is given and value of this is Coulomb. Okay, that is Q means charge. Value of Q is given and you have to find out the value of W. So by cross multiplication you can write W is equal to VQ, and this formula is used over here. Value of V, value of Q, and the answer is 24 joule. Fine. Name a device that helps to maintain a potential difference across a conductor. Simple, it is battery. What is meant by saying that the potential difference between 2 points is 1V? Right now I have discussed. When it will be seen. When 1 joule of work is done to move a charge of 1 coulomb from one point to another, it is said that the potential difference between 2 points is 1 volt. How much energy is given to each coulomb of charge passing through a 6-volt battery? Okay, 6 volt means V and each coulomb means 1. Q is equal to 1C, and energy is equivalent to work, so you have to find out W. V, okay, so V is equal to W upon Q. 6 is equal to W by 1, so work is equal to 6 joule. Circuit diagram. The electric circuit, as here it is shown in the figure, it has a simple cell or battery, a plug key, electrical component, connecting wires. Okay, everything you can see over here. This is a schematic diagram of a simple electric circuit. Here you can see the battery. This is plug key. That is bulb. That is ammeter to measure the current. And these are the wires. Okay. This is the schematic diagram. And here we show all the components of the circuit. And these components are shown by the symbols. Okay, because that is the only convenient method. Conventionally, symbols used to represent some of the most commonly used electrical components. See, if we have to show the bulb, so we cannot draw the bulb. This is the electric symbol for bulb. I showed you the picture of ammeter, but when we are drawing electric circuit, we are not going to draw a meter. We will use the electric symbol for that, and the symbol is over here, ammeter. This is the symbol for battery, and that is for key. Okay, so a continuous and closed path of an electric current is called an electric circuit. This is the definition of electric circuit. An electric circuit consists of electrical devices, source of electricity, and wires that are connected with the help of a switch. And here are the symbols of some commonly used components in the circuit diagram. If we have to use an electric cell, so this is the symbol for electric cell. If we are using a battery or combination of cells, then we will use this symbol. Here you can see more than one cells. Okay, that is the plug key when it is open, and that is the plug key or switch when it is closed. And this is the symbol for the wire when wires are joined. If wires are crossing, then this is for crossing wires. And this is the symbol for electric bulb. That is the resistor. That is variable resistor or rheostat. Variable resistor means we can change the value of resistor. That is ammeter, and that is voltmeter. Okay. So thank you, students. In this session only this much was there. Now we'll meet in part 2. By then, bye bye. Thank you.